Let f of x be 2x plus the absolute value of x. X is real. Prove that f is continuous but not differentiable at the point 0, 0. Let's review key definitions firstly. If limit of f of x when x tends to some value you see from the left is not equal to the limit of f of x when x tends to c from the right, we say that such limit of f of x when x tends to c doesn't exist. And when limit of f of x when x tends to c from the left is equal to the limit of f of x when x tends to c from the right and is equal to some value, we say that such limit of f of x when x tends to c exists and is equal to some value. And f of x is continuous at c when limit f of x exists at c. It means that limit from the left must be equal to the limit from the right. And function is defined at c, and function at c must be equal to the limit at c. Limit of f of x when x tends to c. But it may be enough for IB just to show that limit from the left is equal to the limit from the right. It may be enough. But it would be better to emphasize that function at a considered point is also equal to the limit. And to show that the function is differentiable at some point, we show that limit of the derivative when x tends to c from the left is equal to the limit of the derivative when x tends to c from the right. Or in other words, you can see that when limit of the derivative when x tends to c exists, such function is differentiable. And it means that gradient changes continuously. If a function looks like this, you can see that function is not differentiable at this point. You can conclude it automatically. And for this problem, to show that it's continuous, we should consider limit when x tends to 0 from the left and limit when x tends to 0 from the right. But since we can see the absolute value, we can rewrite this function as we know that the absolute value is just a when a is positive and the absolute value of a is negative, a when a is negative. So it becomes 2x plus x or just 3x when x is positive, 0 when x is 0, and 2x minus x or just x when x is negative. And now limit of x when x tends to 0 from the left, it becomes what? We should consider this, and just substituting 0 for x, we get 0. And limit of f of x when x tends to 0 from the right, we should consider this, and substituting 0 for x, we get 0. And hence, we can see that limit f of x is equal, when x tends to 0 from the left, is equal to the limit when x tends to 0 from the right. And in general, it may be enough just to show that limit from the left is equal to the limit from the right to conclude that it's continuous. It may be enough. Because automatically, since limit is calculated, you just substitute 0 for x, and automatically the value of a function will be the same as the value of a limit. So in general, it is acceptable. But I want to show in detail. So limit is equal, and it implies that limit when x tends to 0 exists and is equal to 0. And it would be better to emphasize that function as function at 0 it's also 0. It's not necessary, but let's emphasize that function 0 is equal to limit and hence f of x is continuous at x is 0. So you can see limit exists. It means limit from the left is equal to the limit from the right. Function is defined. It is defined because x is real. It implies that at the domain includes 0. And function at 0 is equal to limit. Limit exists and is equal to 0, and function also is equal to 0. So function 0 is equal to limit at 0, and hence function is continuous. And to show that function is differentiable, here it's not differentiable, we should consider derivative. And let's find derivative. It's quite easy. So 3x, its derivative is what? 3, 0, 1. So it becomes 3, 0, 1. When x is greater than 0, x is less than 0. So limit of the derivative when x tends to 0 from the left is just 1, and limit of the derivative in general also just substituting this value for x, it becomes what's 3. And since limit of the derivative when x tends to 0 from the left is not equal to the derivative when x tends to 0 from the right, such limit of the derivative when x tends to 0 doesn't exist. So hence f of x is not differentiable. And that's all for this question. The next, the function f is defined by where a and b are constants. Find the exact values of a and b if f is continuous and differentiable. So it is already given that f is continuous. It means what? That limit of f of x when x tends to what? To 1 from the left is equal to limit when x tends to 1 from the right. It's because function is continuous. So just substituting 1 for this to get this limit, so it becomes e to what? To negative 1. Negative 1 plus 2 plus 1 is just 2, so times 2 is equal to limit, substituting 1 into this expression, we can see that it's just a plus b. And we get the first equation, but since there are two unknown variables, we need another equation, and we can get it using that f is differentiable. And since it is differentiable, limit of the derivative when x tends to 1 from the left must be equal to the limit of the derivative when x tends to 1 from the right. Let's find derivative. And you can see that it can be considered as a product. So f, let's write when x is what? Less or equal than 1, derivative becomes, and applying product rule, it's f, it's e to negative x squared derivative times just this minus x cubed plus 2x squared plus 2x and plus e to negative x squared multiplied by negative x cubed plus 2x squared plus x. Derivative is just the product rule. Formula is given in a data booklet, and to find this derivative we apply chain rule, and e to some power e to the power of x derivative is the same. Formula is given in a data booklet, but since there is a more complicated argument according to the chain rule, we apply this rule as given in a data booklet, so it becomes the same. keeping the same argument e to negative x squared, but multiplying by argument minus x squared derivative, and just negative x cubed plus 2x squared plus x plus e to negative x squared, and derivative of this is quite easy, so it's negative 3x squared plus 4x plus 1 plus 1. And finally it's we can factor out e to negative x squared, and it becomes it's negative 2x, so negative 2x multiplying by, we can expand this, so it becomes negative plus 2x to the power of 4, 2x minus 4x cubed minus 2x squared, and plus this, so it's minus 3x squared plus 4x plus 1, and it becomes 2x to the power 4 minus 4x cubed minus 5x squared plus 4x plus 1. And when x is greater than 0, derivative is equal just a, and hence limit when x tends to 1 from the left, all the derivative, so we use this, substituting 1 for x, it becomes what, e to negative 1, and what, 2 minus 4 minus 5 plus 4 plus 1, 0, 3, negative 2, and limit of the derivative when x tends to 1 from the right is just a, and since it's differentiable, negative 2e to negative 1 must be a, together with what, 2e to negative 1 is a plus b, and we need just solve the simultaneous equations. We can see that it can be solved easily by elimination. We can add, or actually we can subtract both sides, let, so let's consider this minus this, so it becomes 2 minus negative 2, it becomes 4e to negative 1, a minus a0, and just b, so it's actually b, so b is 4 over e, and actually a is already found. You can see that a is negative 2 over e, and that's all for this question.